All right, welcome to today's class. In today's class, we are starting properly, still under algebraic expression, looking at question number 1. The question says, given that a plus b plus c equals to 0, show that or prove that, we are going to prove that this expression here or equation here is equals to what? 1. All right, so we say 1 over 1 plus s to the power of a plus s to the power of minus b plus 1 over 1 plus s to the power of b plus s to the power of minus c plus 1 over 1 plus s to the power of c plus s to the power of minus a equals to 1. How are we going to do this? Now, simple trick that I'm going to use is I'm going to since I'm having s to the power of a here, s to the power of minus b here, what I'm going to do here is I'm going to multiply this with s to the power of minus b over b. I'm going to multiply this with s to the power of a over a. You get that? All right. So let's move on. Now, this will remain the same. We are going to have 1 over 1 plus s to the power of a plus s to the power of minus b plus 1 over 1 plus s to the power of b plus s to the power of minus c multiplied by s to the power of minus b over s to the power of minus b plus 1 over 1 plus s to the power of c plus s to the power of minus a multiplied by s to the power of a over s to the power of a. I hope you get that. All right. Now, if you look at this will still remain same. You are going to have 1 over 1 plus s to the power of a plus s to the power of minus b plus s to the power of minus b multiplied by 1 is going to give us what? S to the power of minus b. All right. S to the power of minus b multiplied by 1 is going to give us s to the power of minus b plus, now here is s to the power of b multiplied by s to the power of minus b. Don't forget the law of indices. S to the power of b multiplied by s to the power of minus b will become s to the power of b plus minus b, right? So b plus minus b is nothing but what? 0. And s to the power of 0 is what? 1. Maybe you don't see it. Let's do it. S to the power of minus of b times s to the power of minus b, because they are of the same base. So I'm going to pick one of the base, then I'm going to add the power together because there's multiplication between them, like this. Then it's going to be what? B plus minus b is what? 0. Then s to the power of 0 is what? 1. So that is how we are going to go about that. So here I'm going to have 1 plus, then here I'm going to have s to the power of minus c multiplied by s to the power of minus b. I'm going to pick one of the base again, then I'm going to add the powers together. Minus c plus minus b is what? Minus c minus b plus, now the same thing with this, 1 over, okay, sorry, not 1, s to the power of a times 1 is what? S to the power of a. Now, s to the power of a times 1 is what? S to the power of a plus s to the power of c times s to the power of a. You know, the same base, s, then I'll add the power c plus a plus s to the power of minus a times s to the power of a. It's nothing but what? S, we are going to pick the base s, then minus a plus a, which is still what? 0. S to the power of 0 is what? 1. I hope you get this step. All right. Now, but you have to remember that we are given a plus b. We are given a plus b plus c to be what? 0. And here we are having minus c minus b here. Is it possible for us to have minus c minus b here? Yes. If we move this to the other side, we are going to have minus c. If we move minus b there, this positive b to this other side is going to be what? Minus b. Then we'll be left with what? A. So it shows that minus c minus b is equals to what? A. All right. Here also we are having c plus a. Is it possible for us to make c plus a the solid of formula? Yes. All right. If we make c plus a, or a plus c is the same thing. So let's say c plus a is equals to, if we move this b to this other side, we are going to have minus b. So we are going to replace minus c minus b with what? A. Then we are going to replace c plus a with what? Minus b. I hope you get that. All right. So now this will still remain same. We are going to have 1 all over 1 plus s to the power of a plus s to the power of minus b plus s to the power of minus b all over s to the power of minus b plus 1 plus, now we are going to substitute what here? A. So s to the power of a plus, then we are going to have s to the power of a all over s to the power of a plus s to the power of c plus a is what? That is minus b plus what? 1. Now take a look at something now. You notice that the expression here is the same thing as this, is the same thing as what? This. I hope you get that. It's just like you having, well, let's say 1 over 3 plus 1, let's say 2 over 3 plus 4 over 3. You are having the same denominator. How are you going to find the LCM? You know, since the LCM is same, we can just add the powers together directly. So we are going to say 1 plus 2 plus 4 over what? Over 3, direct like that. Do you get that? All right. So since we are having them to be same, we are having them, so this is 1 here, this is 1 here, this is 1 here. S to the power of a, s to the power of a, s to the power of a, s to the power of minus b, s to the power of minus b, s to the power of minus b. You can see they are same. All right. So we are going to add the powers together. So we are going, sorry, not the power. We are going to add the numerator together. So we are going to have 1 plus s to the power of minus b plus s to the power of a all over what? All over, we just pick one of the terms. So sorry, or one of the expression rather. So s to the power of minus b plus 1 plus what? S to the power of what? A. If you look critically well, you notice that what is at the numerator is the same now. What is at the denominator? We have 1, we have 1, s to the power of minus b, s to the power of minus b, s to the power of a, s to the power of a. And guess what? This, we cancel out this to give us what? 1. And guess what? We are done. Thank you for watching. Please like, share, comment, and subscribe.